Hi everyone, welcome to the second tutorial in our Imaging Science series with the MIT Museum. My name is Brian Murnoff. I'm the Education Coordinator here at the museum, and today we are going to be looking at macro photography. Macro photography is a technique that allows us to image things very, very close up and capture detail that you ordinarily wouldn't be able to see with your camera. Now, often you'll hear that you need a specialized lens or equipment for macro photography. We'll talk about why that is in terms of the physics of the lens, but we're also going to talk about how can you modify your camera just using things that you have around your home to take some amazing close-up images without needing to go out and buy any kind of specialized equipment. Now in this tutorial we're going to be referencing camera settings and some lens physics that we discussed in our first tutorial. So if you're not familiar with how to control the settings on your camera, whether it's a cell phone, interchangeable lens camera, whatever you have, or just need a refresher, please check out tutorial number 1, which will be a great review for that. Now, what is macro photography and what does that actually mean in terms of your camera? When you go to take an image with your camera, that image is going to shrink. And if you really take a second and think about it, well, if you're going to take a picture, let's say, of this bridge over here, then the image has to be smaller in order to fit on the sensor of the camera. So the light's going to go into the camera, the light is going to get focused, hit the sensor, and we're going to end up with the image, but much smaller. So the image is actually shrunk down. But with macro photography, we want to be able to capture the small details of our object. So we need to rearrange our camera a little bit. And you'll notice here we shifted the lens up, the focusing lens, a little bit further up in the camera. And what that is going to allow us to do is take an image very, very close to our subject. So here is this the flower that we're going to take an image of. If we get the camera really, really close to it using this lens, when the light goes through the camera, you actually get an image on the sensor that is the same size, if not bigger, than the original image. And this is what is called macro photography. The image that we're taking stays the same size when it hits the film. So 1 millimeter on our picture is 1 millimeter on our sensor. This lets us capture really, really tiny details. Now you may ask, well, why can't you just take a regular image and crop in? That would be great if we lived in kind of the science fiction world where you could just enhance your image infinitely. But if you don't capture small details, if you don't capture the light that's coming from these small details when you shrink the image down, then no matter how big you make that image, that information isn't going to be there. You're not capturing the information, so you're not going to see it. When you capture something at actual size, we're going to be actually capturing all of this light in here to see those details. So what we're now going to look at is several techniques that you can use to do macro photography with your cell phone or your DSLR, whatever camera that you have, that doesn't require going out and buying any special equipment. The first technique we're going to look at to do macro photography is using a water drop. Now this technique, because we're using a small water drop to help us focus light, only really works well on small cameras, small lenses. So this is perfect for cell phones. Now if I wanted to take a picture of this headphone here, and I'm using a cell phone, and I want to see all the close little detail, this is about as far away that I can hold the headphone and get an image. So when I take this picture, this is what I get. And I can't really see any detail. The headphone is far away, so not really a macro photography shot. If I move the headphone closer to the camera, if I start moving it down here, then the camera won't be able to focus. The lenses inside that camera cannot focus light once you're within a certain distance. So we're going to give it a little bit of help. And to do that, we're going to need a water dropper. You can use an eyedropper, anything that lets you dispense a small amount of water And I'm placing that right onto the lens here. The idea is to get a nice small water drop that holds itself together, and you want it as spherical as possible. So this is a very rounded edge here right on top of my camera. Now I'm using the front camera on my cell phone for this example because it allows you to see the screen at the same time. But you can also use the rear camera. It often is a higher resolution camera for this, and just put your camera on some type of support so you can still take the picture. So I have the water drop on here, and with that water drop, I can now hold my subject, in this case the headphone, super close. So this is now the distance that I can focus at. Now manual focus is ideal here, so you don't want to use autofocus. The camera will have trouble. So you can either use manual focus on your camera app or slightly move the object forward and back to the camera lens to get it in focus. And this is the result. So because we're much closer, we can focus in much closer, we can now start to see all that detail in the metal grating in our headphone. The second technique that we're going to talk about is to use a magnifying lens. Now this technique will work on either a cell phone or DSLR, any camera that you may have, depending on what magnifying equipment you have. To start, if you have a microscope or a magnifying glass, this is a great way to take really close-up photos. So line up your camera with the eyepiece, focus the microscope or the magnifying glass, and take your picture. So this is a really quick way. If you don't have a microscope or a magnifying glass, there are a couple of things that you can possibly find around the house that will allow you to do this, and it actually acts kind of like the water drop. So if you have a laser pointer, you can actually carefully, so make sure you remove the batteries and any power source before you do this. You can actually remove the lens, usually it's a circular clear plastic lens, from that laser pointer. This is a convergent lens, just like the main lens in your camera. And you can see, just like in our first video in tutorial 1 when we talked about the image being flipped, you can see that it's flipping the image when we look through that lens. So this is going to focus our light. And if we take that lens and put it on our camera, just like we did with the water drop, so this is right on our front-facing camera, we can now close this super close to our object and get that macro photo. So now you can see kind of the smooth end of the pencil, or what feels smooth. You can start to see all the little bumps and ridges and irregularities really close up. So we've now turned our camera into a macro lens. The next technique that we're going to look at is to use extension tubes. Now this technique only works for interchangeable lens cameras, so cameras where you can remove the lens and put on different lenses. And an extension tube is a super simple thing to make. So all it is a paper or cardboard tube. You want something thick enough that it'll block light, so you don't want to just use a piece of printer paper, something that lets light bleed through. So use construction paper or a chip can or paper towel roll, something that'll fit well around whatever lens you're using. And this is what it looks like when you're done. So this extension tube is going to let you focus much more closely on your object and take that close-up picture. When building an extension tube, you're going to want to experiment with how long that tube needs to be. The longer the focal length of the lens, the longer an extension tube that you need to get the same effect. So make a bunch of different tubes, play around, experiment, and see what results you can get. So the way that extension tubes work is by changing where the light hits the sensor in your camera. So here's my camera again, and I'm going to want to take a picture of this leaf. And so the light comes into the camera, it gets focused by the lens and hits the sensor, just like any other picture that we're going to be taking. And in this time though, you can see the image is much bigger than the image that we started with. So the extension tube is actually going to help us magnify the image. It's going to, as well as let us focus closer to get the lens closer to whatever we're taking a picture of. So here's my extension tube right here, these red lines. If I didn't have that, the sensor here would be much closer. So let's say it would be here. And so you can see by moving it back, by basically separating the lens from the body of the camera, the light has a little more time to spread out than it normally would have, which magnifies our image. So we're just physically moving the sensor away from the lens, and that lets us get a little more magnification out of our lens. Now, it's important to note with this technique is that the lens is no longer physically connected to our camera. We're just holding everything in place, and we have this cardboard tube or whatever you're using in between. This will unfortunately prevent you from using things like autofocus or setting the aperture of your camera. So you're going to have to do these things manually. Some lenses, depending on the lens that you're using, are going to let you change the aperture using a ring here. So if you can change the aperture manually using a ring on the camera, that's great. If not, a lot of lenses also have a little lever on the back here, and when you push on that lever, you can see the lens opens, the aperture opens. So what you can do is stick a little piece of paper or plastic or something in that spot to hold the lever, and that's going to hold your aperture. Now we'll talk about this a little bit later, but for the most part with macro photography, you want a pretty small aperture, a pretty high f-stop number, because you get a lack of depth of field. So you're not going to want to hold the aperture fully open, but you're going to want some aperture control of your camera. The other setting, as I mentioned, that you're going to lose is focus, is your autofocus. So the best way to handle autofocus in this situation, again, there's no electrical contact between the lens and the camera, is just to physically move back and forth from your subject. So if your subject isn't in focus, just move forward or back until your subject's in focus, and that will work pretty well. The final technique that we're going to look at for macro photography is also only for interchangeable lenses, but this technique is called reversing the lens. So it turns out that you can turn any lens into a macro lens by flipping the lens around backwards on your camera. Now, again, you don't need any specialized equipment to do this. All we're doing here is just holding the two pieces together, but you can also buy different adapters to let you do this without having to hold the lens there. Just like the extension tube technique that we talked about, you're also going to lose control of autofocus and aperture, so focus is going to have to be done by moving back and forth, and aperture will have to be done either manually or using the lever on the back of the lens. Now, the way this technique works is that by reversing the lens, we're moving the main focus element. So the main lens in your camera that focuses the light, brings it in focus here, this convergent lens switches places. So in a regular lens, let's say the lens is positioned about here. In a reverse lens, we're moving that lens farther up in the camera. What that does is now give the light more time to spread out and hit the film. So just like with the extension tube, we move that sensor back so the light could expand. Same thing is happening here. So here the light in a regular lens is going to hit a small area of the sensor, but by flipping this around, the light actually can expand further and cover a larger range of the sensor. So our images, the same points on our image are going to be farther apart, and we're going to get a magnified image. Surprisingly, for this technique, a shorter focal length lens actually gives you a better effect here. So shorter focal lengths will be easier to use than longer ones, but longer ones will still work if that's what you have. So now that you have several techniques that you can use to turn your camera into a macro camera and start looking at kind of the micro world around us and seeing all those close-up details, we need to talk about camera settings. So what are some considerations that you need to adjust for when doing macro photography? The biggest one is going to be aperture. So with macro photography, when you get really, really close to the object, light is coming in from all sorts of wide angles. If you remember back to our first video, we talked about the relationship between the angle that the light's coming in and what's in focus. And because we're so close, those angles are going to make it really hard to get a high depth of field. So a very narrow part of your photo is going to be in focus. So because of that, we're going to need to use a small aperture. So I would recommend probably being, depending on the camera, but f8, f16, even f32 are sometimes what you need depending on how close you're getting to your subject. So you need a high aperture. That causes another problem though, right? With a high aperture, not much light will be coming into your camera. And on top of that, when we take a macro photo, our object is very close to our camera lens. This means that not much light can get into our camera. So how do we adjust for that? So a couple of things. We can do a longer shutter speed. Now, because you're hand holding the camera, if you don't have a tripod, you don't want to slow down your shutter too much, or you're going to get some motion blur. So you have shutter, but then you also have your ISO. So you're going to want to raise that ISO up so that you get a bright enough image so you can see what you're taking a picture of. But then again, if you can't raise your ISO high enough without getting too much noise, if your image is starting to look grainy, or your shutter is open for too long and your image is starting to get blurry because the camera is shaking, another really important part of macro photography is adding light. So I highly recommend whenever you're doing macro photography, bring a flash with you or a flashlight or your cell phone light or whatever you have with you and get lots of light. You're rarely going to have too much light for macro, but because you're so close to your subject, get that light as close to your subject as you can, and that's going to greatly improve those macro images. So with all those techniques, so those are 4 different techniques that you can use to do close-up photography, and you'll again be amazed and surprised at the details that you're going to start seeing on kind of everyday objects. So try these techniques on just things you have lying around your home and or outside, and see what you can discover. Thank you for joining us for this tutorial in our Imaging Science series with the MIT Museum and Koch Institute. We'd love to see your stunning science photos. If you'd like to share them with us, you can share them on Facebook, Twitter, and Instagram, and use the hashtag MITMImagingScience to share those with us. At the end of this program, so on June 20th, we'll be holding a webinar to look at what makes a great science photo, and so submissions have a chance to be featured during that webinar. For more information on the Imaging Science program, other tutorials and other information and resources, please visit the MIT Museum website at the link below, and you will find a list of our other resources as part of the Imaging Science program.